Welcome students. So let's discuss about the composition of functions. So what is composition of functions? We all know that for a function there is some input and according to that we get some output here. Now I'm using this output as an input of another function f, and here I'm getting another output. So for G, input is x and output is gx, and for f, input is gx and output is f of gx. Now I can define another function whose input is x but the output is f of gx. So this function is called composition function or f of gx, or I can write f of g. This is called the composition function. So in a composition function, what I am doing, just combined two functions or more than two functions also I can combine. So the combination of two or more than two functions, and I'm defining another functions, that is f of g is the combination of functions. Now can we define a composition of function for any two function or more than two functions? Or is there any restriction? If there is any restrictions, then what are them? So here I am taking two functions, y is equal to f of x and z is equal to g of y. So in the place of y, I can write the value of y, that is g of f of x. Now what is this x? This x is the domain of the function f. That is, if I define the function f from x to y, so this small x belongs to the set capital X. And what is y? Y is the domain of the function g, that is from where the g is defining. That here I am taking g is defining from y to z. Now this g of f or composition g composition f, this function will define when this range of the function f is same or equal to the domain of the function g. So the range of f is equal to domain of g. If this condition holds, that time this g composition f I can define. Now how many types of composition I can define? I can define just two type of composition, either g composition f, or I can change their places, f composition g. Now what is g composition f? G of f x. And what is f composition f? F of gx. Now when we will find the value of this composition function, we will always move from inside to outside. Inside to outside. That means for this function, I will first solve the fx, then I will find the g of fx. But for here, we will solve first gx and then we solve f of gx. Now take some example. Let's check these two functions are same or they are different. So here I am taking f of x is equal to 2x and g of x is equal to x plus 5. Now remember one thing, this x and this x, this 2x just a variable representing the domain, the elements of the domain of the function f or the function g, but this x are different. This is the domain for f is equal to x to y. This x belongs to from this set x, that is the domain set, and this x are from this y. So these two x are different. Here this x is from domain of g Here this x is from domain of f. Now let's check g of fx. So g of fx is g of fx. What is fx? Fx is 2x, then g of 2x. And what is g of x? That is g of any input is input plus 5 is the output. So here is input is 2x, then means 2x plus 5 is the value. That means g of x is the ultimately function is 2x plus 5. Now what is f of g? That is f of gx. So same process, I am moving from inside to outside. That is, what is gx? Gx is x plus 5. So f of x plus 5. Now what is f of x? That is 2 into input. It is 2 into input is here x plus 5. That means 2x plus 10. So look here, this is 2x plus 5, g of f. And f of g is 2x plus 10. That means they are not same in generally. So in generally, g of f, or in a short I can say this gof, is not equal to f of g as the function. So g of f is not equal to f of g in general. Now how to define the composition function? So let's check how to define the composition function. Here I am taking a function from a to b, f, and g another function from b to c. So let's take an example. Here I am taking fx is equal to 2x defining from set a to b, and gx another function from b to c, where definition of gx is x square. Then the composition of f and g denoted by g of f defined as the function from a to c. Let's check the function is defining from a to c or not. First of all, g of f x, that means g of f of x, and we already know that this x belongs to the set, that is the domain set, that is the set A, that it means 1, 2, 3, 4. That means the input for this function f is 1, 2, 3, 4. Clear? So let's calculate g of f of first element is 1. That means g of f of 1. Now what is f of 1? F of 1 is 2. So g of 2. Now what is g of 2? G of 2 is 4. By the definition of the function, let's check for the second element, g of f2. G of f of 2. F of 2 is 4 here. So g of 4 is 16 here. G of f of 3 is g of f of 3, and f of 3 is 6, that is g of 6, and g of 6 is 36. Now g of f of 4 is g of f of 4. What is f of 4? Is 8, that is g of 8 is equal to 64 here. So look, for 1 I am finding the image 4, for 2 I am finding the image 16, for 3 I am finding the image 36, for 4 I am finding the image 64. The domain of this g of f is the set A, since 1, 2, 3, 4 is the element 1, 2, 3, 4, that's the set A. And look at the range set 4, 16, 36, 64, that is the set C. That means g of s is defining from the set A to C, and we already know g of f x means g of fx for every x belongs to the set A. That is the input for the function f. We already defined it. Now when this function will define g of x G of f will define only when the range of f and the domain of G is equal. Range of f is B here and domain of G is B here. Both are equal. That time this G of f I can define. Now let's check f of G is defined or not. So what is f of G? X. F of Gx. Here x is input for G. That means set B. That is from 2, 4, 6, 8. Now let's check f of G of 4. That means f of G of 4. What is G of 4? 16. Now f of 16. So for the function f, input is 16, which is not possible since in the input of this set A is 1, 2, 3, 4. Only 4 elements are there. 16 does not belongs to the set A. That's why we can't find the value of this f of 16. So f of G I can't define. So when I can define f of G is defined only when range of G is a subset of domain of G. That is, range of G is here. See, it's a subset of domain of F, that is A. Then if C is a subset of F, that time F of G is defined. And then here the domain of f of G will be domain of G. That is, here I already defined this X we will choose from the domain of G. Now check these two conditions by some example. Here is function is given f from 1 to 3 to 1 to 5, and here is the definition of the function, that is image of 1 is 2, image of 3 is 5, image of 4 is 1. Another function G is defined from 1 to 5 to 1, 3, and here is the definition of the function G. 1, image of 1 is 3, image of 2 is 3, image of 5 is 1. So find G of f and f of G. First check this G of f and f of G exist or not. For existing G of f, what I need, that range of f should be equal to the domain of G. What is the range of f? Is 1, 2, 5 is equal to the domain of G. Domain of G is again 1 to 5. They are equal. That means G of f I can define. So what is G of f? So G of f of x. This x belongs to the set 1, 3, 4. Now check G of f of 1. G of f of 1. What is f of 1? Image of 1 is 2. That is G of 2. What is G of 2? G of 2 is 3 by the definition of the function G. Now check G of f of 3. G of f of 3. What is f of 3? F of 3 is 5. So G of 5. Now what is G of 5? G of 5 is 1. G of f of 4. G of f of 4. Image of 4 is 1. So G of 1 and image of 1 is 3. 3. So look, for the G of f, that is the Goff function, input is 1, 3, 4. That is the set A 1, 3, 4. And it is defining to the range set is 1 and 3. These two elements are there in this range set. So Goff is defining from 1, 2, 3 this set to 1, 3 this set. That means the domain of X to the range of G. So here are the elements of Goff. 1, image is 3, 3, image is 1. From here you can check 4, image is 3. Now what is fog? Is it defined or not? Let's check. For define this fog, the range of G should be belongs to this domain of if. What is range of G? Range of G is 1, 3. Now this is belongs to domain of f. Domain of f is 1, 3, 4. Now 1, 3 belongs to this set. That means this is a subset of 1, 3, 4. That means f of G is defined. Now check this. What is f of G? So for f of G, so here is input is from G, that is 1, 2 and 5. So for 1 I can check f of G of 1. What is G of 1? Is 3. F of 3. And what is f of 3? F of 3 is 5. So similarly you can check for 2 also, for 5 also. Here is the element of f of G. Here is the solution. You can check. Moving to the next problem. Here these two functions are given from real number to real number. F is defining and fx is cos x, and g is defining from real number to real number. Gx is 3x square. Now you don't need to check the function g of f and the f of g is defining or not, since the sets are same here. All are real number. So I can say range of f, that is this, is equal to the domain of g, and the range of g, this is a subset of domain of f. So both the functions are defined. Now you need to check these functions are not same. We already discussed that these functions are in generally they are not equal. Let's check by an example. So g of f of x. G of f of x. Now what is f of x? F of x is cos x. We will move from inside to outside. F of x is cos x. Now what is g of x? G of x is input. If input is x, then the output is 3x square. So if input is cos x, then output is 3 cos x the whole square. That means 3 cos square x. Now for f of gx. F of g of x. What is gx? 3x square. So f of 3x square. Now if for if x is input, then output is cos x. So if input is 3x square, then the output is cos of 3x square. Now check 3x square x and cos of 3x square x. These two functions are not same. Hence we prove that GOF is not equal to 4. Here is the solution by an example. You can also show that by an example these two functions are not equal. So here the function f is defining from R to R. Function this is defined x square minus 3x plus 2. Now you need to find f of f. Now f of f is defined or not? Since f to f, then range of f is equal to domain of f. That means they are same. So I can define f of f. Now f of fx is f of x. Now what is f of x? F of x square minus 3x plus 2. Now I am taking this value is equal to y. So I can write f of y. So what is f of y? Y square minus 3x plus 2. Now put the value of y in this equation. You will find the solution of f of x. That is, here it is, solution is given. Next, three functions are given from a to b, b to c and c to d. Then you need to show that this equation. It is associative property. Now we need to check this h of g of fx, this and this h of g of f, this is same or not? So I can write h of g into fx of fx. So I can write, just break this composition. So I can write h of g of f of x. Now from here I can write h of g of f x. So these two functions are same. That means if these three functions are given, then that will follow the associative property. This property is known as associative property. So here is your solution. You can check. Here is your next problem. A function f is given, fn is equal to 3n, z to z, that means integer to integer. G is from integer to integer, and g of n is defined like that. For if n is multiple of 3, then it will be n by 3, otherwise it will be 0. Now you need to show that g of x is iz. Now what is iz? I means identity function and z means it is defining on the set of integer. In this manner, we will write this identity function. I means the identity function and this z means where the function is defining, the set where the function is defining. If I take any integer value, let's take 3, then identity function of 3 is always 3. Let's take another function or another value of integer. This I'm taking 5 here, so that will give you 5. So this is the identity function. Now you need to check that this is identity. Gof is identity, but fog is not identity function on Z. Now you can check Gof is exist since the range of f is equal to the domain of G. Since Gof is exist, now check Gof is identity or not. G of f of x. Now what is g of f of x? F of x is 3x and g of 3x. Since it's a multiple of 3, so I will take the first definition, that is n upon 3. That is 3x by 3. 3 cancel x. So I can write this one is identity of z. So if I take the input x, I will get the output as x. Now you need to check this FOG, that is F composition G is not an identity function. Now check F of G for the element 1. So F of G of 1, since 1 is not a multiple of 3, so I will use this definition, that is F of 0. Now F of 0 is 0. Here the input is 1, but the output is 0. That means it's not a identity function. Here is your solution. You can check the solution from here. Here is your next problem. A function given from a to b and another function g is given from b to c, such that Gof is identity. That means g of f of any element I can take from the set A, that will give you the same value x, that is the same as input, and from x is from the set A. Now you need to show that f is 1 1 and g is on 2. So what is the 1 1 function? 1 1 function is if I can choose x1 x2 from the set A, since it is defining from the set A, such that f of x1 is equal to f of x2, then if it imply that x1 is equal to x2, then that time the function is 1 1. So here f of x1 is equal to f of x2. Since G is another operator and G of f is defining, so I am taking both sides the function G. So G of f of x1 and G of f of x2. This function also I can write G of f of x1 and G of f of x2. Now this is identity function. That means this input should be the output. Here is the input is x1, here is the input is x2. Then output are also same. Then x1 is equal to x2. That means it is 1 function. So I already proved that f is 1 function. So if you can take any element from the set A such that f of A is equal to B in the set B, since this is the domain set and this is the range set for f. Now you need to show for onto function g of B is equal to A. Here g of B I can write g of B is g of f of A. Now g of f of A means gof of A, which is identity in A, that means A. Here you can check, that means G is onto. Here is your solution. You can check the solution. So moving to the next problem. Here is one function is given greatest integer function, another function is given absolute value function. So what is greatest integer function? That is f of x is box x, and g is absolute value function, that is g of x is mod x. Now you need to find fog of minus 3 by 2, that is f of g of minus 3 upon 2. Now gx is mod of x, so apply it. Gx is mod of this. Then f of mod of minus 3 by 2 is 3 by 2, and f of 3 by 2 is 1, or you can write box of 3 by 2 and this value is 1. So from here you can check g of f is also 1 and their sum is 2. Here you need to find this value and the value is 2. So moving to the next problem. Fx is equal to x square and f is defining from R to R. G is defining from R to R and gx is this, where x is not equal to 1. Why x is not equal to 1? Is it needed? Of course it is needed. If x is 1, the denominator will be 0 and that time gx is not defined in this set. So x never be 1. So find f of g and g of f and these two values. Now what is f of g? Now here you can check the domain and range. So from this range and domain of g, f and g, we can say this fog and gof both are exist, since we already discussed it previously. So let's find f of g of x. F of g of x. What is g of x? X upon x minus 1. So f of x by x minus 1. Now what is fx? Input is x, then output is x square plus 2. Here input is x by x minus 1. So output is this x by x minus 1 the whole square plus 2. So this is the function f of g. Now what is g of f? G of f of x is g of f of x. What is f of x? X square plus 2. So g of x square plus 2. Now what is gx? Gx is if x is input, then x by x minus 1 is the output. X by x minus 1. X by x minus 1. That is x square plus 2 by x square plus 1 is the function. So now check these two values and find the answer. Here is your homework. Here one property you need to show. Here you need to find fog and gof function. This will you will solve. I will not help you. And here, this is true. You need to show by an example. And here, you need to show the golf is not equal to 4. So any problem or any queries is there, but free to ask. Thank you.